is Ms. DB. In this video, we are going to review the concept of domain and range. And we're also going to identify relations as discrete or continuous. So we have discussed this in a previous folder, but we're going to keep talking about functions for the rest of this year, so it's really important that we understand. So this first part here is a bit of a review. A continuous function, when you graph it, you can draw a continuous line. You don't stop or start. You can do it in one motion. It's a smooth curve or line. No holes, no gaps, no jumps. That's continuous. When you graph a discrete function, you're only going to get points. You don't connect them. It's just points on a graph, like a scatter plot. So examples of continuous functions are things like growth, time, height. Money is often continuous if you count fractional parts of cents. Volume, the real numbers are continuous. And most of the functions that we will graph as continuous functions. Discrete functions is more real-world things like how many pets do you have, how many children do you have, anything that you can count with the natural numbers, like if it doesn't make any sense to include fractional parts in it. Integers, whole numbers, natural numbers, those are all discrete. Now, when you talk about the domain of a continuous function, we are going to use an inequality like greater than or equal. Or sometimes we'll just say that it's all real numbers. For example, a line, y equals mx plus b. Well, in this case, it's y equals 0.5x plus 1. There is no value that x cannot be. The domain is what are the possible x values. In the case of a linear function, it's all of them. It's all real numbers. But sometimes it doesn't make sense to include maybe the negatives, or maybe you're not allowed to have negatives. And in that case, your domain would be x is greater than 0. Or maybe x is greater than or equal to 0 if you could include 0. Sometimes your domain will be within a range, like maybe it'll be from -5 to 5, including those endpoints. So that's how continuous function domains are written. And remember, domain describes the x values. In a discrete function, for the domain, you just list the x values. So in this function, the domain would be 1, 4, 5, 7. They're right there. That's the domain. Now the range is based on the domain. So in our graph up here, we said that the domain can be any of these numbers. It's all real numbers. Look at the y-axis right here. The y-axis there's points that are below it. The graph goes below the x-axis, so there's negative numbers. It goes above, so there's positive numbers. There's nothing that y cannot be either. So in this case, in this continuous function, the range would also be all real numbers. If you have a discrete graph, the range is the y values that you can get after you plug in those x values. There's a typo right here. This should say range. I'll fix it. When you see your worksheet, hopefully it won't say that. All right, so the first few problems, you're going to name whether a relation is discrete or continuous, and then you're going to determine the domain and the range of the relation. Now it says relation rather than function because we have not yet discussed how to tell if it's a function. Many of these on here are functions, but we'll get to that in a later assignment. All right, so in this relation for number 1 and 2, they're just a set of points. To tell if it is discrete or continuous, if it's a list of points like this, then it's discrete. So these are both discrete. To find the domain of a discrete function, all you do is list the x-coordinates. So in number 1, the x-coordinates are 0, and then 3, and then 90. And the range is the y-coordinates, so 4, 20, and 33. If a number appears more than once, you only write it down once, and you should write them in order from least to greatest if you can keep track of that. Number 3 is a linear function. It's a line. We talked about that. That will be a continuous function. Unless the domain is limited in some way, like it says that x can't be something, then your domain will be all real numbers. And in linear functions, the range is also all real numbers. So you would write that for both of them. Now, in the problems on this page, it's a little bit more to think about. Let's look at number 6. Each mother cat in a house has 3 kittens. There are 4 mother cats. Is this a discrete or a continuous function? Well, first you might want to think about what the question might be asking if they went one more step, and it's probably going to be something like how many kittens are there in total. These are kittens. You can't have fractional parts of kittens, so you would say that this is discrete. And the domain is how many, here, let's try to write a function for this. Let's see. Kittens is equal to mother cat times 3. How many mother cats is like the x in this case? So it says that there are 4 mother cats. So our domain is only, I guess, if we were only counting 1 cat, 2 cats, 3 cats, 4 cats. And the range, if there was 0 mother cats, there would be 0 kittens. If there was 1 mother cat, there would be 3 kittens. If there was 0, 1, 2, I'm on 2 mother cats, and so on. So you would just keep going until you get to 4 mother cats. I skipped 3 over here for some reason. So that's an example of a discrete function that you would not be able to write like all real numbers for mother cats. It's not possible. When it comes to wages, it kind of depends on your job. Some people are paid to the closest hour or maybe to the closest half hour, but many jobs are paid to incremental. So if you work 1 hour and 59 minutes, you'd be paid for 1 hour and 59 minutes, which might make it more of a continuous function. If you are paid only by the hour, then it would be discrete. So I think usually it's more of a continuous function. It would be a graph. You know, if you're working, if these are your hours down here, and these are your wages. If you work 1 hour, it's this, and it goes up, and it's incrementally rising at a constant rate. So probably continuous, and then your domain is going to be how many hours could you work in a week. So think about what a reasonable domain is. It's not all real numbers because we can't work negative hours. And there'll be a limit. Most people don't work or can't work more than 40 hours a week, and maybe less than that if you're under a certain age. Before then your wage might increase. So your domain might be x is between 0 and 40. You could write it that way. Or you can describe it in words too. And then the range is based on that. So think about if I worked for 0 hours, I would get 0 wages. If I worked all the way up to 40, it says it's $10 per hour. So what would be the max you could get for your range? And then fill that part in on your worksheet. All right, in number 8 through 11, it says they are continuous relations. Graph using technology to better visualize. Then state the domain and range and attach your graphs for extra credit. So I have Sketchpad here that I'm going to use, but you could also use Desmos, or you could use GeoGebra to graph these. And if you're not going to attach them for extra credit, you could also graph them using a graphing calculator. But you can't attach those, so. All right, so in Desmos, in Sketchpad, this is the one that you have to access by the student desktop. You go to Plot New Function, and then you type in the part after the equal sign. In Desmos, you can type the whole thing, y equals absolute value. Absolute value of x is found in Sketchpad by going to the functions and then down to ABS, which stands for absolute, and then x. So when I graph it, I get this is my graph. So the domain of this and I can move this around or shrink it in a little bit. These would continue in both directions. There is no limit on the domain. I can have negative numbers, I can have positive numbers, there's no holes, there's no gaps. The domain is all real numbers. But the range, let's look at the y values. It's never negative because the absolute value of a number always gives you a positive. So the range is going to be only positive numbers. Now it can be 0. So for the range of this, I would probably write that y is greater than or equal to 0. To make the greater than or equal sign, you can take the greater than sign and then you can underline it using the tools in Word. That's how I usually make it. And so it's greater than or equal to 0. You can also write y is greater than or equal to 0. That's good enough too. And the range was, or the domain we already said was all real numbers. Let's look at y equals 1 over x as a graph. I'm going to delete this one and do 1 divided by x. These are examples of functions we'll look more at this year, but this time we're just looking at how to find the domain and range of them. This is an interesting function. We see that x can be all of these numbers on the negative side and can be all of these numbers on the positive side, but it's never equal to 0. Look at, on both sides, it approaches 0, but it never actually touches 0. And that's because we're not allowed to divide by 0. So for your domain, you can say all real numbers except x cannot equal 0. Now, there is a symbol for cannot equal. It's an equal sign with a slash through it, but you can just write cannot equal 0. Good enough. Now let's look at that range. The range of this, all these values for y, all these values for y, but it will also never equal 0. So when you write the range, you'll say the same thing, all real numbers, except instead of x, you'd say y cannot equal 0. It'll never equal 0 because there's no way for it to equal 0 without x being 0. The next two, I'll do real quick too. You've seen these ones a lot more. Y equals x squared is a parabola. This is a quadratic function. So it doesn't look like x goes all the way over and all the way over, but if you went up and up and up, you would see it gets wider and wider and wider and wider. There's no limit on what x can be. X can be all real numbers. However, the range is never negative in this function. So you need to say that the y value is always going to be above or equal to 0, much like we did in number 8. And then number 11, that's a linear function. We've talked about these before. When you graph it, you'll probably find that there's nothing that x can't be and there's nothing that y can't be. So then you can write all real numbers for domain and range. Number 12, this is an example of a mapping or a function map. So it's showing that a is going to b is going to a is going to c, and so on. We'll use these again when we talk about whether or not we have a function or not. The elements in the first oval, these are your domain, and you just list them with commas between them. And the elements in your second circle oval are the range, and you just list them with commas between them. Do not list the same number or letter twice. So in the domain, there's A, B, C. You would just write A, comma, B, comma, C. It's okay if there's not the same number in each. We'll talk about what that means later. Here's a discrete function in 13. So when you list the domain and range of these, the domain is just the x values. So this looks like 1. I can't tell completely if that's 2 or 2.5. And you'll just give your best estimate of what those values are. Maybe put a ruler up there. It's hard for me to tell. I could draw vertical lines through them. Let's see if that helps me at all. Okay, I'm just going to like do this one. That's not exactly in the right spot, so I'm going to try to move it. Oh, it looks like that one's at 5. Where's that one at? That's not 5. So you give your best estimate of what that is. Maybe it's 3.6 or something. 2.5 maybe. So you list the domain, and then for range, remember range is the y values. So the y values are going to be definitely not as many. There's only 2 y values. There, and remember when you write the range, you do not have to write all of them. There's only 2 that show up and they're just repeated. Then I cannot get that line to line up right. That's too high. I think it's going through 2. But I'm going to give up. So you can make that judgment about where the y value is, and that is the range. And then here's another parabola, and that's it. So you're just going to practice with domain and range, and in this section, discrete versus continuous. If you have any questions, please let me know, and have a wonderful day.